Okay, so this is Will again, and now what we're going to do is we're going to go right into making a seal-in circuit. So last time what we had was we had our green light, which works really nice, but it doesn't want to stay on for us. And that's what a seal-in circuit does for us. So what we're going to do right now is we're going to go offline, and we're going to disconnect. And right now I'm just going to I'm going to delete these whole rows. I can put them in later if I need them again, but I'm going to just delete these, and I'm going to delete this one, but I'm going to keep my green lamp in. So now we have our green lamp. Now what a seal-in circuit does is a seal-in circuit, because this is only temporary, I need something to seal in this signal even after it goes away. So what happens is when I push on this push button, this signal goes high. So if I put this signal around this signal will be high, so even after this signal goes away, this signal can still control it. Remember, so what I have to do, and first let me show this. If you left click to highlight and then right click, here is where we aren't adding a rung. What we need to do is add a row after the cursor. So I'm going to do this, and now I'm going to put a normally open contact in that space, and I'm going to call it my output. So I'm going to make this my Y003, and here is when we go into our edit and we get to use our line erase and line signal. So I want to put a line that connects this point up to here. So I can go any of these directions. I just want to connect it there. Okay, so let's take a look at what we got. So now I've got a circuit that when I press this push button, I am going to turn on this green lamp as before, but now when I press it on, this turns this on. So even after this signal goes away, this signal is still on. And it just seals in this circuit. So remember, we're trying to go from this power rung to this output. Now, because there's two different rungs and they tie together, that's what that line put in there. I mean, it's a single rung, but we have two different branches, and what we call each one of these is a branch. It's a branch in this rung. So I can either go through this one to turn it on, or, and it's an OR circuit, or I can go through this branch to turn it on. So when I push the button, this turns on, which makes this all of a sudden become active. When we press the push button, this becomes active, so this becomes active, and even when we let go of the push button, this is still going to remain active. It seals in the circuit. So let's take a look at that. So we're going to connect up, and we're going to download into it. So we just need to read the project into the PLC. We're going to write it into the PLC. And again, you know, every time when we hit OK and we go to the stop mode, our lights that are on our stack light are going to go out. Because right now it's being programmed, so it's wiping out all the information. Now it has a new program in there. So I'll say OK, and now I'll go into run. Now nothing happens. As soon as I press the start push button, that green light's going to go on, and it's going to stay on. And it's going to, right now as we have it configured, it's going to stay on forever. This green lamp, the only way it goes out is if I turn my PLC off, or if that lamp burns out. This circuit right now, it has sealed in this push button. And that's all fine and dandy, but eventually if we have a start push button, we need to have a stop push button. And what we're going to do is put that one in. So we have the stop push button. And let me just go to here. This is slightly counterintuitive. Our start button and our reset button, and I'm talking about the physical buttons over here, those are normally open push buttons. And so they're wired with 24 volts over here, and we don't get 24 volts over here until we press that contact closed. So when we press that closed, when we put this normally open gate in our circuit, when we push that, then this becomes active, and then it passes voltage through there. So we use a normally open contact. Now our stop push button is a normally closed push button, and again it has 24 volts wired here, which means in its normal, when I'm not pressing that push button, I've got 24 volts here. So if I want to pass this through, I need still a normal, in my circuit, I need to have a normally open contact. Even though the stop button is normally closed, I want to have a normally open symbol on my PLC program, because when I open this and there is not voltage, I want that to stop our signal from going through, because I want to turn the signal off. So let's just put in the circuit and maybe it'll be clearer. So here I'm going to put in another normally open. Now this is going to be X001. That is my stop push button. So we'll highlight that and we'll go into our address picker. And here it's going to be our stop PB. Okay, and make sure you hit OK. So now when I press the actual physical button on here, okay, when I press that button, all of a sudden I'm going to get 24 volts, which activates this, which will conduct through here. Now this one already has 24 volts, so it conducts. So even though this says stop push button, it wants to be, and even though the stop push button, the actual physical stop push button, is normally closed, I need to show this as a normally open contact, because I want it to turn on when I hit the start button, which means I need to have flow going through here. Now that stop push button, the actual physical thing, already has 24 volts going through it to the input at X001. So this really needs to be a normally open push button. And I know it's kind of counterintuitive. You think if the push button is normally closed, this should be normally closed, but in the case, and really your stop push button is the only case that you normally run into where it's not like that. But you need all these to be normally open. So let's connect up and show us how this works. So we'll connect up, and we don't want to read it. And we're going to write it into our PLC. And when it lights up with the aqua, or the color here, the cyan color, it'll be kind of obvious what's happening. So we're okay. We'll put it into stop mode, come back into run mode. All our lights will be off. Okay, and you can see, because there is 24 volts, this is conducting through. So all I need to do is hit my start push button to turn this on, and it will latch. Until I hit my stop push button, well, let me show you what happens. When I actually hit my stop push button, that's when it's going to not, conduct through my switch. So in this configuration, I want it to conduct, so this has to be normally open. Okay, so let's take a look at what happens when I hit my start push button. It'll be just like before. It'll latch on, and it'll stay on forever. Now, the thing that's going to turn this off, eventually, if the start turns it on, I need to stop to turn it off. So when I hit stop, it goes off, and it'll stay off. And it'll stay off until I once again hit the start push button. And again, that's our seal-in circuit. This is going to be in every single one of your circuits. We're going to use this for the most part. We're going to use start, stop, and reset, and we'll have those wired up. Now, this is really not quite what I want, though. It's close, but not quite. So I'm going to go offline, and what we really do here is we don't light the green lamp from this. What I really want to do is I want to go in here, and I'm going to change that to, well, let's take a look at our C bits. I'm going to change this to one of our C bits. So if I go to the top, we already called that input 1. And, well, it doesn't matter. We'll call, we'll make this C2. And, you know, it's kind of odd. This address picker is really a two-step. I click on it once to pick that I want it out here, then I have to do it again. And what I'm going to name this, and I name it like this in all my projects, is I'm just going to make it, name it Start Process. A lot of people would name this, and if I could spell, it would say Start Process. A lot of people call this System Run. And, you know, either way, just so you know what it means. So I want my Start Process to turn on my green light, but I didn't want my green light here because really, when I don't have it started, you know, when it is started, I want my green light on. But when it's not started, I want my red light on to tell me, hey, you're not started. So if you start pressing buttons, then you will start. So what I want to do is I want to go in here and I want to add, actually I want to add 2 rungs. So I'm going to add a rung after, and I'm going to do it again and add another rung after. So now when I'm not in Start Process, so I want to go up here, when I'm not in Start Process, so I want to normally close contact, and now I want it to be this C2. When we are not in Start Process, I want my red light on. And before we determined that our red light, and we can take a look, if we're uncertain, always pull up these ellipses and it'll take you into the outputs. Now we want our red lamp, so that's Y001, so we're okay with that. And I want to go in here, and when I am in the Start Process, so when it is active, so I want the normally open contact. Now I'm going to go into my address picker again. And now I want to go into my Y bits, and I want my, I want to go into my C bits here. And I want my Start Process over here. So when it's normally closed, the red is on. When it's open, I want my green lamp on here. So I want my output. And now here's where I want to go into my Y bits. So I want the green lamp. Okay, so this is the type of program that we're going to start out with. Everything is going to have this first one, which is the CLN that says I'm starting my process. So unless this is high, nothing should happen. That should lock out anything from just automatically running, unless it is in Start Process, or, you know, alternate if you want to call it System Run, fine. So we're going to connect up, and we're good there. So we'll just say connect. We don't want to read the project that's in there. And again, I almost never do. And we'll write it into the PLC. It'll go through its start process to load the program. And, you know, we got the program in there. And now we'll go into the run mode. So now, when I first turn on, that red lamp is going to be on, and it's going to say, no, you are not started. Okay, so there's the red lamp. Now, as soon as I hit the Start push button, the green lamp will go on, and it'll be just like before. So I'm going to hit my Start push button, the green lamp is on. And it's going to stay in that until I hit the Stop push button. When I hit the Stop push button, that breaks the CLN circuit, the red lamp will go back on. Okay, and if I want to restart, I hit the Start push button. So you can see how the CLN circuit, along with a couple additional things, and you know, here's what we use these internal bits for. It's not an input to the system, and it's not an output to the system, but it's a bit that we kind of derive from these inputs and outputs to control something else. And you know, you find as you get more and more into these programs, use these internal bits all the time. You know, you have a few inputs, a few outputs, you know, you add some counters, some timers, but to keep the status of what's going on internal to the PLC, you have to use these C bits, these internal memory bits. They're the most used bits that you'll have in your PLC programs. So that is how you do a CLN circuit. Now, we're going to actually start programming some examples. The first example that we have in the manual when we talk about PLC actually coding it is a sort of garage door that goes up and down. And that's what we're going to show off here next time. So now we're actually going to start doing some real coding for real problems that exist in the real world. This is just how you want to make sure you're starting and stopping your system. But now we're going to take a look at real world examples, I guess. So we'll see you next.